So we've been asked for dy dx, and there's no derivatives here, so we'll need to differentiate with respect to x. First term, 0. Second term, just 2x, because I'm differentiating with respect to x. And now for the other side, we're going to have two product rules. The first one will be x ln of y, so we have a u and a v. The derivative of v is the hard part. Ln of y would be 1 over y. But then because I'm differentiating with respect to x, and this is y, I have my dy dx term. So now I'll put that together. You'll notice I took the shortcut of combining 1 over y times my u, which was x. That's where that term comes from. And now we're going to do the product rule on this next term. Again, u and v. So if u is e to the y, then u prime would be e to the y times dy dx, our implicit term. Sine is just in terms of x, so v prime is cosine of x. Now we'll put this together. So now after all of that, we have finally differentiated with respect to x. So we need to find the dy dx terms. Here's one of them. And here's the other one. Everything else can move to the other side. So I'll subtract the cosine x e to the y term, and I'll subtract 1 times ln of y. And when I do, I get as follows. You'll notice only terms with dy dx and a multiply show up on the left side. And since dy dx is in both of these terms, I'm going to factor it out. Dy dx times everything that's left, e to the y ln y plus x over y. And that equals everything you see here. Now all we have to do is divide by what you see here. E to the y ln y plus x over y. And when I do, I get as follows. One thing I realized, I took the wrong v for this second derivative. V should have been sine of x, not ln of x. So I've changed that everywhere. You may have seen that as you were watching the video. And so now dy dx equals 2x minus cosine x e to the y minus ln of y all over e to the y sine of x plus xy.